Hello, today I would like to go over the Chapter 10 Excel workbook slides, just kind of give you a run through of the terminology that you'll be using in Excel and to kind of let you know exactly what is expected when working with an Excel spreadsheet. So we're going to start with cell references. And so a cell reference is really referencing what type of cell you are working with. And so in Excel, you're going to be able to create your Excel worksheet that implements relative, absolute, and mixed cell addressing and understand how formulas execute when written and copied into different cells. Also recognizing situations where it's best to use cell addressing based on what type of data you're working with, whether you're hard coding values or trying to make something flexible in your Excel formula. So your formula cell is really that cell in which a formula is written, and I'll get into demonstrating this with our Excel demo file here in a little bit. Your cell reference is the use of a column or row, so either like A3 or C5, D4, to designate the contents of a cell into a formula. And so in this case, our formula here, A3 plus C5, is saying that we want to add the contents of cells A3 and C5 together based on what cell this formula is in. Then your target cell is a cell specified by a cell reference. And so that A3 or C5 are both cell references, so those are your target cells. Your target cell is always in the same relative position to the formula cell, no matter where the formula is copied when you're using relative addressing. So that means that if you have a formula in, say, cell A4, and we are going to copy that down to D4, because we are staying in the same row of row 4 in our Excel spreadsheet, you are going to only move over to D4 when you copy that cell, and it will move by column. So here's an example of relative addressing. So in this Excel spreadsheet in B3, we have this value of 10. In C5, we have the value of 15, and in D8, we have a value of 5. But in reality, there are actual cell references going on, and so we've got a numeric value of 10 in cell B3, whereas we've got a formula cell or a formula in cell B or C5, which is equivalent to B3 plus 5. And so that's where we end up with our 15 in C5. Once you hit enter on that formula, that equal signs creating that formula will give you that 15, because in B3 we have 10 as our numeric value. When we copy and paste this formula into D8, it updates accordingly based on how many columns we either move to the left or to the right, and how many rows we went either up or down. And so when our formula relates to B3 in C5, for our cell reference back to B3, we are referencing something that is up 2 rows and left 1 column, whereas when we copy from C5 into D8, you are going up for your cell reference to C6, up 2 rows and left 1 column, which gives us C6. Thus, we get a value of 5 in that cell. For absolute cell addressing, it means that our target cell is always the same formula cell, no matter where the formula is copied. And in this case, we use our $ symbols in order to hold our columns and our rows constant. And so this is useful for constants or for parameters in a formula that you may wish to change later. Some of the more equivalent constants that we use this for, say, were gravity, where an equation is going to be using g of 9.8 meters per second squared. You need to reference that constant throughout your formula, regardless of where it is copied. And so our example of absolute cell addressing is, again, we've got our values of 10, 15, and now D8 contains the numeric value 15, because when we add those $ before both the B and the 3 in cell C5 for our target reference of B3, B3 stays constant. So the dollar sign before the B means that column is staying constant, and the dollar sign before the 3 means that that row is staying constant. So we are holding that value or that cell reference constant throughout. And so again, that cell reference goes up 2 rows and left 1 column, but when we copy this, because we've held those constant, it doesn't change, thus we get 15 now in D8 instead of 5. And then mixed cell addressing is when your target cell is always in the same row or column, but the other column or row maintains the same relative position to the formula cell, no matter where that formula is copied. So in this case, where we held our dollar signs constant for our absolute cell addressing, we are only putting a dollar sign either in front of the row if we want to hold the row constant, or in front of the column if we want to put the column constant. So we're back to 10, 15, and 5 in cells B3, C5, and D8, respectively. This is because we are holding only our column constants. We added a dollar sign only in front of the B. And this allows us to hold that column constant but change what row we are referencing. And so when we relate C5 to our B3 cell reference, when we update that and copy our formula into D8, we end up with B6 plus 5 instead, which gives us that value of 5. So moving on to functions and just working with our formula cells in Excel, we want to make sure that we are properly using Excel functions, especially those listed in the tables within the textbook. Understand the limitations of certain functions, and so there are different ways that you can use functions or different syntaxes for your functions that will allow you to do different things. Especially your trig function arguments, those are in radians, not in degrees when you start working with them. And then given an Excel equation with built-in functions, we want to be able to predict the outcome and interpret common error messages in Excel and offer possible solutions to those. And so some of the basic rules about functions are that trig functions must be in radians. Like I said before, they are not in degrees, and so you have to use another function either to convert it into degrees or do a calculation to convert it into degrees when working with those trig functions. All of your functions are always followed by a set of parentheses. So in the case of pi here, we have the word pi and then a set of blank parentheses. If we were to have, say, a function of sine, we would have sin for sine and then a set of parentheses and whatever is in the parentheses is what we are going to do the sine in radians of. So don't assume your function names. Whereas sqrt is a square root function that works in Excel, cube root is not a function. And so there are different ways to get at and specify what root of a you want to do beyond a square root. And then use your correct function name. So in order to do an average, you actually use the full word average, not AVE or AVG in your formulas. And so some of the functions that are built into Excel, again, these are tables that are already in your textbook, so refer back to them. And it kind of walks you through both what the function is and what the definition of what it's trying to do in Excel. And we'll use quite a few of these. Your cosine, degrees, pi and radians, sine and so on are also going to be used for MA5 when we do our mini Excel project to finish out our MAs. EXP, power, product, square root, and sum are going to be used in calculations within some of your assignment problems. We will use EXP a lot and power in our graphing module here in another week. Some of your statistical functions in Excel are average, max, median, min, and then standard deviations, variances, things like that. The most common ones we will use for this course are your average, max, and min functions. And then there are a bunch of other functions that give you other values or can help you calculate things. A common one in math concepts is being able to find the slope and intercept of a value based on a set of pairs for X and Y values for graphing. Being able to round, so there's round, round up, round down functions that will help you round numbers. Truncate, so TRUNC allows you to truncate a number to a specified number of digits. So if you only want 2 significant digits, then you can truncate a number to that. And then count functions, which are really helpful if you need to count something within a spreadsheet. And then there are common error messages that are most likely going to pop up as you are learning how to use Excel. And so these are, again, outlined in your textbook in a couple of different tables. So use these as reference. One of the ones that you'll get most commonly is divisible by 0, meaning that you've got a 0 in your denominator. And so you need to look at what that cell reference is so that you can determine where that 0 is coming from. Or a cell reference being incorrect. So here the pound sign with REF and an exclamation point, meaning you've got an invalid cell reference back to something else. Or pound sign NA. So if a value is not available or it doesn't know what it's looking up, you'll get that error quite a bit. And so there are other ways. So like I said, there are error values, and if an error is coming up and it's correct in how it's calculating, say we are dividing by a 0 and we want to just leave that cell blank instead, we can actually use the if error statement to do so. And so your syntax for your if error formula is our equal sign. So every formula always begins with an equal sign. And then you write if error, and then we start with our parentheses as this is a built-in function. You're going to tell it what value. So in this case, we are telling it B4 divided by A4 is our value that's occurring in C6, and then what value we want to output if it is an error. And so here, we're doing that division out of C6 based on this formula of B4 divided by A4. We want it to output a blank cell in place of having that error message. And so a double set of quotation marks indicates that we want a blank cell. So now our spreadsheet would turn out to have a blank cell in place of an error message. So I'm going to stop there, and we are going to get into our first Excel spreadsheet.